Multi-channel pipettes can be a huge sum and time saver when you have like a lot of tubes or samples or things like that that you need to pipette from one place to another. Like a normal pipette, you pipette up once, so you aspirate once and you push down and dispense a single volume. Unlike a repeater pipette, which we talked about yesterday, where you suck up once and then you dispense over and over and over the same amount, with a multi-channel, you're dispensing the same amount, but these can be different liquids if you're setting things up in tubes, or they can be the same liquid if you have it in a reagent reservoir, and you're going to be dispensing that liquid into the corresponding tubes or plates or whatever you want to do. And so it can be really helpful when you're setting up like assays, so experiments and this sort of thing, when you have maybe a lot of samples. And there are some caveats when using it. There's some like nuances. You have to be really careful that when you're doing things, you make sure like all the levels are even. You have to do things make sure you're not at an angle or things will be uneven, things like this. So let's get into those details. When it comes to multi-channel pipetting, evenness is the name of the game. You want to make sure that the level of the liquid in each of these different pipettes is going to be exactly the same. And to ensure this, you need to make sure that when you go and you pick up your tips, you're doing this evenly, you're vertically above the tips, you're applying even pressure, not too much, just enough. And that then when you go and you suck up the liquid, you're not doing it at an angle, you're doing it straight above vertically, right below the surface, and suck up. And you want to visually look and make sure that you have levels, the same amount in each. And now what you can do is you can go and you can dispense your sample. And when you do this, you want to make sure that it gets all the way out of all the different tubes. So again, you want to apply pressure vertically, both when you're putting the tips on, as well as when you're going into the liquid, you want to be straight above it. If you get a bubble in the bottom of the tube, this is really, really common, especially when you're doing the blowout, so you're blowing things out. Now you have that bubble, and that can cause a problem when you go to try to pull it up. So what you want to do is you want to go in, you want to go below the bubble, pull up the air, and now push the sample back onto the surface. You might have to do it a couple times to really get rid of that air bubble. But now you can see that that air bubble has moved to the top, and now I can pipette up the liquid. I've also kind of messed up the ones around it because it's hard to do this on the screen, but normally this would be in like a rack or something sturdier, and so you can really see things. But it's really important to be aware of that when you do that blowout, you're often going to get the sample stuck on the air on the bottom. So what can be kind of helpful is to kind of do that blowout, not at the very bottom, but like on the edge, so you're making sure that the liquid contacts it and it all gets out, but you're on the surface, so you're not introducing bubbles into the bottom. And then to get rid of those bubbles, what you can do is you can then go like spin it or something like this, but pipetting out the air and then back the liquid, if you're not able to do the spinning or something like that, that can be an option. And so that problem with the air also happens when you're doing a lot of mixing, so just be cautious of that. Know that it's going to impact what gets pulled up and what gets pulled out. Sometimes when you get bubbles, what you can do is you can kind of just like pipette up and down a bunch of times, and this can even them out. If you still have bubbles stuck at the top, you can kind of just push things all the way out, but beware that some of it might jump back up here. And so then you want to make sure that you even out those lanes before you go and you load your sample. So I've got some serious bubbling going on here, but by pipetting up and down a bunch of times, I can then remove most of them. But you want to be careful that when you're pipetting up and down, you're not grabbing bubbles onto the surface of here. If you have a problem with one of the samples where it's not coming out of the tip, so there's a problem with this tip. So what I would do is I would take this tip out, remove these, and now I go and I deal with this one individually and try to fix it. Push the liquid down to the bottom, remove any air, and now pull up and make sure that it's level. Sometimes what can happen is that one of your samples might be not cooperating, and so you're like, okay, I'll just leave that one in there, and then I'll go and I'll take another pipette and I'll transfer it. But I like to use the same multi-channel to do it instead of using a single pipette to fix it, because that way you're making sure that it's going to be the same amount, whereas you might have slight differences in calibration between your different pipettes. If they're off, that could then influence things. So by using that same pipette, you can kind of hopefully keep things more consistent. But they can be really, really helpful. Even if you do your best, there can still be problems with the evenness. Or where you can't pull things up evenly, or you can't push things out evenly. And if this happens to you, this can mess up your experimental results. And it can mess them up in like a systematic error way, where every time you might have the same problem in each of these wells on this side, say. Because maybe when you go and you pulled up the tips, you had a tendency to be stronger with your right side. You're doing it like this, and you're gonna have higher pressure here. And so now what's gonna happen is that the sample level might be higher over here than it is over here. And this is gonna happen in all of your samples. And so say every time in your experiment you had your sample E over here and sample A over here. And so now every time sample E is going to get a higher amount than sample A. This is going to make it seem like sample E might be like higher expressing or higher something or another, when really it's just that you pipetted more. So this is one reason why it's good to rotate your samples. If you're doing like replicates or things like this, you want to rotate their position throughout the plate to account for differences that might happen because of your pipetting, and this can help even out those systematic errors. And then you also have those like random errors where the things like there's a bubble caught or something like that, and that can happen anywhere in your plate. But to avoid that, you want to make sure that you're keeping a good eye on the liquid when it's going in and when it's going out. When you're doing this pipetting, sometimes you might not have a full 8 or a full 12 if you're using a 12-lane multi-channel. In this case, what you can do is you want to make it so that the tips that you're using are in the center, where this is going to be the most even. Out on the edges, this is where you tend to have the most problem. So say I wanted to have 6 samples instead of 8. Now what I could do is I could go in, I can take my rack and I can kind of just manipulate things. So use your this to move the tubes away, the pipette tips away from where you want them. And now what I go and do is I'm going to go and I'm going to load these in the middle of my pipette. And now I'm going to have the evenness. And I can draw up and I can get level samples. But if I were to be on the edges, they might not be as even. So it's helpful to kind of like keep an empty rack after you go through one, so you have some space so that when you open the new rack of tips, you still have room that you can manipulate things around and get the tips how you want them set up before you go and you pull up. When you are moving from one place to another, so these can swivel. Just make sure you keep track of what you're actually doing. So if you have it loaded like this, and then you go and you swivel it and you load it, well, now your samples are backwards. So make sure that you are keeping track of what samples are where. You can use different size multi-channels depending on how many samples you have and how big of fraction samples you have. So if I wanted to, I could use like a 12 mil P200. And now I'd be able to suck up to 200 microliters. So say I wanted to do 100, and voila. It's easier to see things are level when you have a bigger amount, and it's easier to avoid those bubbles if you have a bigger amount. But you don't always have that bigger amount, and so then you have to be really, really careful when you're doing those small volumes, because every little difference is going to make, every little bit is going to make a difference. So any bit that's stuck in the tip, any bit that's stuck on the outside, all of those can be problematic, and this is especially going to be an issue if you have viscous solutions. When you're using a multi-channel pipette, you want to make sure that you make a lot more than you need, so that you have enough to like put it in a reservoir, or if you're using it in a strip, you need to make sure that you have extra in each of the different tubes to account for things sticking on the sides and that sort of thing. So normally whatever you're doing, you want to make extra sample to account for liquid loss during transfers and things like this. But with the multi-channel, you have to account for that extra liquid in every single place where the pipette tips are going to be contacting, and therefore you have to make a lot more. So that's one of the downsides about using a multi-channel pipette. And so hope that helps you understand how to use a multi-channel, as well as some of the caveats. So make sure that you're always straight above, even pressure when you're putting on the tips, when you're pulling up the liquid, when you're pushing out the liquid. Beware of bubbles. Make sure you're checking the levels both when the liquid comes up and when the liquid goes down. Make sure this thing that you don't see like an angle, make sure that you don't see bubbles, and you should be good to go.